We see the light from supernovas all the way across the cosmos. But what we're seeing isn't the explosive first flash. That's just the opening act before the main event.
Supernova are some of the most energetic events in the universe. The galaxy has hundreds of billions of stars in it, and yet the death of this one star can outshine those 100 billions of stars.
One of the interesting things about supernovas is that when the star explodes, it's not at its maximum brightness immediately. It takes days and weeks.
The first flash is the explosive part of a supernova, blasting tons of matter into space around the dying star. But it's this ejected debris that makes supernovas shine, often glowing brighter than the explosion itself.
Heavy elements are formed inside the cores of massive stars, and even heavier elements are formed during the explosion event itself.
As the star rips apart, temperatures and pressures are immense. The elements that once made up the layers of the star fuse together, creating heavier elements. And some of these are radioactive.
The decay of these radioactive elements actually produces light that gives it more brightness over a longer period of time than it otherwise would have.
This cloud of brightly shining matter can last for months and sometimes years. These supernova remnants light up the universe like cosmic fireworks.
These are oftentimes beautiful, beautiful things in the night sky because you see remnants of everything that the supernova has generated in its explosion.
But these are more than pretty light shows. They're crucial for the evolution of galaxies and solar systems.
Necessary ingredients, things like sulfur, things like phosphorus, things like carbon and oxygen, and even the elements necessary to build a rocky planet like the Earth itself can only be formed inside of massive stars and can only be spread through supernova explosions.